Imagine waking up tomorrow and discovering that the world you see, touch, and move through is only a thin slice of reality. Like a single page torn from an impossibly thick cosmic book, and hidden just beyond your perception are entire directions of space you never knew existed. Directions you cannot point to. Directions that might explain why gravity is so weak, why particles have mass, and why the universe exists in the precise way it does. What if I told you that right now, as you sit and watch this video, you might be surrounded by extra dimensions, curled up so small that they slip through your senses like shadows through a wall? Welcome to Cosmic Horizon Hub, and today we are diving into one of the most mind-bending questions in modern physics. Do extra dimensions exist? To understand this idea, let's start with something familiar. You live in 3 dimensions of space and 1 of time, up and down, left and right, forward and backward, plus the relentless flow of time pushing everything from past to future. This feels complete, intuitive, and final. But physics has a long history of revealing that reality is far stranger than it appears. There was a time when atoms were considered indivisible, when space was thought to be absolute, and when time ticked the same for everyone everywhere. All of those ideas turned out to be wrong. So when physicists began to ask whether our universe might have more than 3 spatial dimensions, they weren't just being imaginative. They were following a pattern that has repeatedly led to deeper truths. The idea of extra dimensions first appeared in a serious scientific context over a century ago. In the 1920s, a mathematician named Theodore Kaluza and a physicist named Oscar Klein proposed something radical. What if gravity and electromagnetism, 2 forces that seemed completely different, were actually manifestations of a single force acting in a higher dimensional space? Their idea suggested that if you add just 1 extra spatial dimension to Einstein's equations, electromagnetism naturally emerges. But there was a catch. If this extra dimension exists, why don't we see it? Their answer was both elegant and strange. The extra dimension is real, but it is curled up, compactified into a tiny loop so small that it is invisible to us, smaller than anything we can directly measure. Imagine an ant walking along a tightrope. From far away, the rope looks like a one-dimensional line, but up close, the ant can move not only forward and backward, but also around the circular surface of the rope. The extra dimension is there, but it's hidden unless you're small enough to notice it. This simple metaphor opened the door to a revolutionary idea. Dimensions can exist even if we cannot perceive them. Fast forward to modern physics, and extra dimensions are no longer a fringe concept. They sit at the heart of some of the most ambitious theories ever proposed. One of the most famous is string theory. According to string theory, the fundamental building blocks of reality are not point-like particles, but tiny vibrating strings. Each vibration corresponds to a different particle, like notes played on a cosmic violin. But here's the twist. For the mathematics of string theory to work, the universe cannot have just 3 spatial dimensions. It needs 10 or even 11 dimensions, depending on the version of the theory. These extra dimensions are not optional. Without them, the equations fall apart. The universe, as described by string theory, demands extra dimensions the way a symphony demands more than 1 instrument. Now imagine space not as an empty stage, but as an intricate origami structure folded in ways we cannot see. The extra dimensions might be compactified into complex shapes called Calabi-Yau manifolds, each with its own geometry. The shape of these hidden dimensions could determine the properties of particles we observe, such as their masses and charges. In this view, the reason electrons behave differently from quarks might be written into the geometry of dimensions smaller than a trillionth of a meter. It's a stunning idea. The universe becomes not just something that exists, but something carefully shaped in higher dimensions. But there is another approach to extra dimensions that feels even more dramatic. What if extra dimensions are not tiny and hidden, but large, maybe even infinite? This is the idea behind brane world theories. In these models, our universe is like a 3-dimensional membrane, or brane, floating in a higher dimensional space called the bulk. All the particles and forces we know, except gravity, are trapped on this brane. Gravity, however, can leak into the extra dimensions. This could explain one of the biggest mysteries in physics: why gravity is so weak compared to the other forces. Think of shouting underwater. Your voice feels weak not because you are whispering, but because the sound energy spreads out in all directions through the water. In the same way, Gravity might appear weak to us because it spreads out into extra dimensions beyond our universe. This idea leads to astonishing possibilities. There could be other universes, other brains, floating just a microscopic distance away from ours in a higher dimensional space. They might be so close that, in principle, gravity from those universes could slightly influence ours. We could be cosmically adjacent to entire realities and never know it. At this point, you might be asking the most important question. This all sounds fascinating, but is there any evidence? Or are extra dimensions just beautiful mathematics with no connection to reality? This is where things get truly exciting. Physicists have proposed ways to test the existence of extra dimensions using experiments and observations. One approach involves particle accelerators like the Large Hadron Collider. If extra dimensions exist, high-energy particle collisions might produce signs of them. For example, energy could seem to disappear from our universe, carried away by particles traveling into extra dimensions. Physicists look for missing energy signatures that cannot be explained by known physics. So far, no definitive evidence has been found, but the search continues, and each upgrade to these machines pushes our reach further into the unknown. Another line of evidence could come from gravity itself. At very small distances, gravity might behave differently than predicted by Newton or Einstein if extra dimensions exist. Experiments have tested gravity at millimeter and sub-millimeter scales, searching for deviations that could hint at hidden dimensions. While current results still agree with standard theories, they also place constraints on how large or small extra dimensions could be. The absence of evidence is not evidence of absence. It simply tells us where to keep looking. There is also a cosmic angle to this story. Extra dimensions could have played a role in the early universe during the moments just after the Big Bang. They might have influenced cosmic inflation, the rapid expansion that shaped the large-scale structure of the cosmos. Subtle patterns in the cosmic microwave background radiation, the afterglow of the Big Bang, could one day reveal fingerprints of higher dimensions. We are, in a sense, reading the universe's baby photos, searching for signs that reality once stretched into directions we no longer see. Now let's introduce a twist that feels almost like science fiction, but is taken seriously by physicists. What if extra dimensions are not just small or hidden, but dynamic? What if they can change shape or size over time? In some theories, the extra dimensions stabilized early in the universe's history, locking in the laws of physics we observe today. If they had stabilized differently, the universe might be radically different, perhaps incapable of forming stars, planets, or life. This raises a profound question. Are the laws of physics the way they are because the extra dimensions settled into a particular shape, and could they have been otherwise? Suddenly, extra dimensions are not just a technical detail, they become a key to understanding why the universe is hospitable to life at all. Of course, there are critics. Some physicists argue that extra dimensions, especially in string theory, may be impossible to test, at least with current or foreseeable technology. They worry that these ideas, while mathematically rich, risk drifting away from experimental science. This debate is ongoing and intense, but even critics acknowledge that exploring extra dimensions has led to powerful mathematical tools and deep insights into quantum field theory, gravity, and the nature of space and time. Sometimes the journey itself reshapes our understanding, even if the destination remains uncertain. Let's pause and ask a direct question, the kind that keeps scientists awake at night. If extra dimensions exist, why does our everyday world feel so solidly three-dimensional? The answer lies in scale. Just as bacteria are invisible to the naked eye but still real, extra dimensions could be hidden by their small size or by the way matter interacts with them. Our senses evolved to navigate a world where these dimensions are irrelevant to survival. Reality may be far richer than the interface we perceive. Another question follows naturally. Could we ever travel through extra dimensions? The honest answer is that, for now, this remains firmly in the realm of speculation. If extra dimensions are extremely small, accessing them would require energies far beyond anything we can imagine. If they are large but inaccessible due to the way forces are confined to our brain, then travel might be fundamentally impossible. Still, the idea challenges our intuitions and expands our sense of what the universe could allow. In a way, extra dimensions force us to confront the limits of human perception. We like to think that what we see is what exists, but physics keeps reminding us that reality does not owe us simplicity. From quantum fields filling empty space to spacetime itself bending and stretching, the universe has repeatedly revealed layers beneath the surface. Extra dimensions may be the next layer waiting to be uncovered. So do extra dimensions exist? The most honest answer is that we do not yet know. They are not proven facts, but they are not wild fantasies either. They arise naturally from serious attempts to unify the fundamental forces and explain deep mysteries about the universe. They make predictions that can, at least in principle, be tested, and they offer a vision of reality that is both humbling and awe-inspiring. If extra dimensions are real, then the universe is far larger and stranger than we ever imagined, not just in terms of distance, but in terms of structure itself. The space you move through every day could be a thin slice of a vastly higher dimensional cosmos. And if they are not real, the search for them will still have pushed physics to new heights, revealing unexpected connections and deeper principles. Either way, the question itself is worth asking, because it reminds us that the horizon of knowledge is always expanding. If this journey through hidden dimensions stretched your imagination and made you see the universe in a new way, let me know what you think. Do you believe extra dimensions are real? Or do you think reality stops at what we can observe? Share your thoughts in the comments, give this video a like if you enjoyed it, and subscribe to Cosmic Horizon Hub for more deep dives into the mysteries of the universe, because the more we explore, the more we realize how much remains hidden just beyond the edge of what we can see.